your question back. The packet filter is placed in the far periphery of the network. So just connected to the router, and so a packet filter will be right to the router. Sometimes it could be part of the router itself, but it could be a separate firewall. Then you have a stateful firewall, and then you have this proxy firewall. I call that application proxy. I'll tell you what a proxy means. So application proxy firewall, and then you could really have your network where you have your hosts. Now the hosts may run their own firewall. You might have heard of personal firewall, right? So each machine can run its own firewall, personal firewall. So this could be the sequence of firewalls you could have. So the reason why this is a kind of preferred sequence is the packet filter, as you know, it's stateless. It means it doesn't, it just takes decisions on a per packet basis. So the packets can be processed quickly. So if at all some packets have to be brought, they get brought quickly. Okay? And then a stateful firewall takes some time because it has to look at the sequence number and all the other information and decide whether it has to allow them or not. So it does take some more time compared to packet filter. Whereas application proxy takes a lot of time. So you want an application proxy firewall to process only those packets that pass the test that are done with these two firewalls. Okay, so only those packets that you want to really be let in the network. Okay? So that's why you let the application proxy firewall to work on as few packets as possible, those packets that successfully go through these two tests. Okay? And then still, you may not be able to, like for example, all these three firewalls or dedicated firewalls running on separate hardware, like I said last time, on the network boundary. So, but still they may not be, for example, you cannot configure all these three firewalls to filter packets according to the needs of a specific host. So for example, a user running on a host may not like to get packets from certain website, as like advertisement website or things like that, right? So if you want to filter packets with a fine granularity, you want to configure your personal firewall to do all those things. Okay? So as a network firewall, they will filter packets that kind of don't meet the requirements for the network. So if as a network-wide decision you don't want to allow certain packets, these firewalls can do. But if you want to implement certain host-based decision, like I don't like this packet, then you have to configure that in a personal firewall. You cannot force network firewall to do that. Okay? So same thing with intrusion detection. So if you want certain things to be again prevented from your host point of view, you want to configure IDS. So that's why when you look at a personal firewall, there's no clear distinction between well, we have a separate set of topic on personal firewall, but let me talk right away. So when you come to personal firewall, you don't have a clear distinction between an antivirus scanner or a firewall, IDS, intrusion detection system. They are all in one kind of. And moreover, a personal firewall runs on the same host on which you're running all the other applications. And I told about these firewalls, I told you don't run any other application program on the host in which you're, on the hardware in which you're running these firewall software, right? Whereas a personal firewall, you run them on the same machine in which you're working. So there may be some vulnerabilities in your application or your operating system, like the desktop operating system, so they can be kind of exploited by someone to penetrate your machine. Okay, so just putting a personal firewall is not sufficient if you want to be connected to the internet. So if you are in a network, it's better to also have all these other firewalls. Okay? But if you are, so imagine the kind of vulnerability your machine has if you go home and you're an ISP. The ISP doesn't provide any of these firewalls. Whereas if you're in Jackson State Network, the computers in your office, can have a personal firewall, but then the Jackson State network also provides all these solid firewalls. So your computers in your office are well protected. But if you go to your home and you're in the internet and the internet service provider, they don't provide any of these firewalls. So it's very important, you need to have a very good personal firewall if you're on the internet with your personal computer. Okay? Now, so let's get back to this proxy, application proxy. So there are two kinds of application level firewalls. One is called the proxy firewall, and then you can also have what's called a reverse proxy. So the proxy firewall basically protects the internal clients. So so you may have a network of some computers. So these are like a client computers. And you could have one firewall, that is this proxy firewall, and this is facing the internet. This is a server or even other users connected to the internet. So proxy firewall acts as a gateway trying to monitor what packets or what machines users are trying to connect to your network. So this could be, for example, a scenario is your say again like in your office network, and you have some files in your office network and you want to access them from home or wherever from the internet, right? So you don't want outside users to connect your office computers right away. You really want a very strong kind of security guard kind of person to stand on the way, right? So that's what this proxy firewall will do. It will make sure all packets are trying to get into a network where these machines are really kind of not that sophisticated to protect themselves. Okay, so this acts like a very strong security guard trying to make sure who is trying to access this machine are kind of authenticated. So one way is these machines may have their own authentication mechanism, but the proxy firewall can have its own authentication mechanism. So all users trying to get in have to be validated first with this proxy firewall, and then have to be able to then will be only able to connect. An example is a VPN, like if you are trying to, if you have used Red Hat 3, this programming server that we have here from off campus, you may have to use this VPN connection to get through. So that is kind of like a proxy firewall. So you have to get validated. Okay? And also this proxy firewall makes sure that, for example, even some packets that are sent out from this client computers to the outside world, we don't want to send some virus code out of your computer, right, to the outside world. So the proxy firewall will make sure whatever packets that are leaving the network are also kind of good packets. You don't want to go and corrupt some server or some other user, right? So they kind of take up the role of a proxy server, trying to validate the packets that are trying to leave this network. Okay? So even when you do some caching and all the stuff, when you're visiting some website and all these things, the proxy server caches all that information. So every time you visit a website, the web page could get loaded from the proxy server rather than trying to contact the real server. So only when you kind of refresh and make sure the updates have to come from the real server, then the information will be fetched from the real server. Okay. Now the reverse proxy is a kind of opposite version of it. So the reverse proxy case, you have a server computers in a network, and you want to protect the servers from any attack. So typically you have clients trying to connect to this server. So same principle, but here the reverse proxy server takes up the role of the clients. So if at all some client wants to kind of contact a particular server, the reverse proxy server makes sure that what are the actions the client is trying to do on the real server won't do any damage. So it will kind of execute all the code, the data portion of this packet coming from the client, and make sure if at all there are followers inside, they don't do any damage. So they kind of take up the role of the server and process the packet and then forward inside if they cannot do any damage. So this could be like, for example, if I'm hosting a book site like Amazon.com or something, like we saw this cross-site scripting attack, right? And all the SQL injection attacks. So if you're sending some information that could launch a SQL injection attack or a cross-site scripting attack and all those things on the real servers, right, then you'll be in trouble. So you want to pass through all your data packets, right, and make sure there's no such JavaScript that can launch the attack. So if the real server cannot do that, the proxy server should be, the reverse proxy server should be capable of filtering all those packets that have those malicious scripts that can launch those attacks. Okay, so the reverse proxy server will kind of process all the data portion of the packet to see if it has some malicious scripts. Yes.
Dr. Meg, when we did that project 4, I'm thinking it was project 4 we did with the scripting. Do you remember my computer did like a blocking of that cross? It said it was unable to do one of the attacks because it prevented it by some mechanism within it. Was that an example of that?
That I think you are trying to just locally test on your personal computer, right? So your web browser had the intelligence to figure out that you're trying to launch an attack. So it depends on web browser. So certain web browsers, I think you're using like what, Internet Explorer or Chrome or something. So it was having the intelligence to figure out you're trying to launch a cross-site scripting attack. So it didn't allow that script to be executed.
So it had nothing to do with that
It
then?
didn't have to do with the server because you're just on a local machine. But the same effect would be felt if you're trying to connect from an outside machine to a server inside, and if you're having such scripts to go through, then the reverse proxy server will do the same thing.
Okay.
Yeah? Yes.
You remember when you said to prevent the malicious code, as the developer, you can send like multiple cookies, right? But the database will say which information, or like each information they will save in the database, or
You have to have all the cookies. You have to say all the cookies. It's like, have you gone to bank lockers? You have to have multiple keys. You cannot just use one key to open it up. So you will have one key, the bank official will have one key, and so on. Like that, all the cookies will be saved, and your credentials have to be validated for all those cookies. Okay. Yes.
An example of proxy server would be a DMZ.
Be what?
DMZ.
DMC. It's a kind of DMC, but I don't think I have it here. So since you pulled it up, let me tell you what DMC is.
But I thought like that, not cutting you off, but to be the military zone, I thought it had to be like a server.
Right, that's
There's-
what I'm trying to say, yeah. DMC is not formed of firewall, it's formed of servers. I think I have it in the networks class thing. Looking for a figure so that I can use it too. Okay, so a DMC is like this. So you know, most of the time the attackers trying to attack servers and try to launch some denial of service attack and all those things. But it look like a Jackson State network. You not only have servers, you have a lot of like desktop machines, office computers, things like that. And so there will be more of such machines compared to the number of servers, right? So when you develop all your server software, in Drill, we have to have a lot of security features with them, right? So with the idea behind this is called demilitarized zone network. So what it means is you put out facing the internet only the servers on a separate LAN or a separate network. That's called the DMZ network. So that network won't have any of your client machines or kind of those dumb machines that don't have that much of intelligence to bear any attack. Okay, so all your weak clients and workstations will be in an internal protected network, and also the important servers will be in the internal protected network. Whereas the ones that you put outside are typically like a DNS server, domain name service server, web server, and probably an email server. Okay? Of course, it's not still recommended to just put them outside facing the internet. You have one layer of firewall, a front-end firewall that faces the internet, and all packets have to go through this firewall to attack the DMC network. But still, all the attack packets will first attack only the DMC network before they can attack the application, the thing that is internally protected. Because they have to go through another layer of firewall, and then they have to attack all these things. And typically the target is only those servers like a web server or email server rather than any client machine. Okay, so you protect all these things internally, and you put outside this kind of what is called the DMC network. Demilitarized means it's not without sufficient equipment basically, or removing all the equipment basis thing. But you still put a firewall as a front-end firewall before them facing the internet. So any attack package will first target will have to go through this firewall and then attack this DMC network. Okay? But the DMC also is like it's like if something is attacked here, you kind of take more precaution in protecting the internal network. Okay, and the one kind of idea is you put it out there so that you're prepared for an attack. So basically, but then you want to use that as an indication that your other machines will be probably under attack. Okay, so you kind of like it's also related to the honeypot case. You put it out so that someone will be kind of motivated to attack that. But here you don't just put it as it is. You are still protecting them. Okay, but since these are mostly the targets, you just want them. Okay, so if at all someone wants to attack, let them attack, but let me protect everything else inside. Okay, that's the idea. Okay. So that's the reverse proxy. So we saw two scenarios. One is to have like an office computers, and from outside you're trying to connect and use them. And the other scenario is run your book site or something. Okay? So if someone wants to purchase a book, like you did that project, right? So you want them to be able to only view the price of each book or something, or the menu, right? You don't want them to send some script that could change the pricing of your menu. So you want only the read-only kind of features. You don't want someone to be able to update your menu. Right? So if you could, like you had the project experience, so if you could let some Java scripts inside, they could update your database. Right? So the reverse proxy server will kind of watch out for all those malicious scripts and filter them right away instead of letting them to go to the server. Okay?
So it's protected from the outside.
It protects again, yeah, from the outside. Attacks from the outside. So we saw personal firewall, right? So
You want to go in the hallway?
one thing we should also notice is that firewall is not a solution, or it's not at least the only solution. Okay? So there could be reasons that are beyond the control of a firewall to attack a network. Okay? So one simple reason is if you see a firewall like what gets into all this network connections and all these things. But if you have a virus on a flash drive and you come and plug it on a computer and inside a well-protected network, then a firewall cannot save it, right? So if you go to all the defense organizations, I worked as a summer faculty for 8 weeks in Air Force last summer. They didn't let us use any flash drive on any of their computers. Okay? So no flash drives. Because as I said, if you could have all sorts of network firewalls, but if you could have a virus on a flash drive and you could install it. Of course, the laptops, we cannot take our laptops or computers inside, they provide their own laptops and they have all the security features. You cannot install any software, you cannot do pretty much any installation, but still, they don't let us use your flash drive or anything. Okay, not even, I think they let use a CD if you want to really copy anything, you have to use a CD to copy and then take out.
Symantec has a feature.
Huh?
Symantec has a feature which integrate a group and put all people in that group. You're not able to use that flash drive for external.
Right. So what I'm trying to say is, so a firewall is not the only solution. So if something happens in the network, we can't say my firewall didn't work. Okay, so certain things like internally happen. So same thing like an employee who's not very happy with the organization, he can mess up something, right? So he can write his own virus code on the computer sitting over there and then mess up something, right? So these are things that are beyond the control of a firewall. And also, if only the network, the firewall is only exit or entry point for a network, then you can say, okay, something came in, the firewall didn't catch it. But if you have a computer and you have a kind of a separate connection to the outside internet, like you have a modem or something running or some other way to connect to the outside internet, the network, then again, and if that is not a protected interface, then someone can penetrate through that interface. Okay, so you cannot again say the firewall is weak because the firewall cannot monitor every interface. Whatever it's connected to, it can monitor that connection. But if you have a separate interface to get out the internet, then a firewall cannot catch that. Okay. So on the top of it, as I said last time, we also have an intrusion detection system. So if at all something still manages to penetrate through a firewall, we have this running inside the network, and that can raise some alarms and kind of prevent any attacks. Okay? And they kind of complement each other. The IDS can then be alerting the firewall. So I saw packets with some of these signatures coming from this IP address, port number, and so on. So don't allow any more packets from this IP address port number, so that the firewall can be updated. Okay. Okay. So next, let's look at how this secure shell protocol operates. You might have used it to connect to your again Red Hat 3 server from any computer. It's called SSH. There is a more recent name for it. It's called Transport Layer Security, TLS. It has almost the same features, but so whenever I later use TLS, I'll refer to secure shell. It's the same thing. Okay. So I'll tell you the kind of sequence of message exchanges we go through to do the secure shell connection. Okay, so I've seen some people using as a misnomer, I run my Java program on secure shell. Secure shell is not really any IDE or anything like that. It's just an interface to connect to your remote computer. So you have redhat3.jsml.edu as a server. Okay, and you're connecting to the server using this protocol. Like FTP is a protocol. Secure shell is also a kind of a program allowing you to connect to the server from your computer. Okay? So when you want to connect as a client to a server, you want to make sure here server is not a fake server. So you are probably sending some sensitive information or something. So you want to make sure the server is a genuine server to which you are connecting to. Same thing the server could do, like when you are trying to connect to secure the Red Hat 3 for the first time, right, using this secure shell SSH, you would probably get a pop-up message or kind of what you call a message box telling, or you kind of accepting this connection with all the certificates. Have you ever experienced it? You might have just said yes, but you have to say yes. If you say no, then you cannot connect. Okay, so that will happen for the first time. You are trying to connect from a particular computer to this server. That will happen because that computer may not have a public key certificate. So if you do not have a public key certificate for a particular computer, it won't let you to connect. So if you still want to get connected, that's when you have to press that yes, otherwise that server won't accept connections from this computer. Okay? Okay, so the first step is to request for a connection, and then when you once you request a connection, the server is going to send its public key certificate. So you all know what the public key certificate is, right? So public key certificate of the server. So that will help you to authenticate the server, whether it is the real IP address and all this domain name and all those things. So the client authenticates the server certificate, and then it will, once the client is satisfied, this client is going to send a suite of or a list of encryption algorithms. So typically when the client and server try to connect, we also saw this in the IPsec protocol, because the client may not be able to support all the encryption algorithms the server can handle, so the client typically sends its full list of encryption algorithms that it can support, and the server will have to choose from that list. Even if you go to a restaurant, it does happen sometimes. Nowadays they have a menu, but some restaurants, they don't have a menu. They'll just tell what are the items they have for that day, and you have to choose from that, right? So you may want to eat anything you want, but it may not be available there. So similarly, the server may support a lot of other encryption algorithms, but the client can support only from a list. Alright, so in the meantime, the client could also send its public key certificate, and it's probably an option, but most of the time it's not really, it's optional, so it's not mandatory for the client to have its public key certificate, but if the server demands it, the client should be able to send its public key certificate. Okay? And so that the server can authenticate the client. And then, so once they exchange their public key certificates, you know what a certificate has, a public key of the other side. So they can encrypt all their communication using either a public key or sometimes using the private key to provide authentication. So the server will choose from this list of encryption algorithms one particular algorithm to use for encrypting all the data packets they are going to exchange. So that is encrypted with the name of the circuit algorithm is encrypted with the private key of the sender or the server to indicate that it did come from that server. So private, when you encrypt something, the private key of the sender, it provides you authentication. It's like a digital signature. So then once the client learns that the server has selected that particular encryption algorithm, depending on the key size that algorithm uses, okay, so the client will generate a session key. Okay, so if it is a DES or something that uses a 56-bit key, then this client will select randomly generate a session key of that size and encrypt that with the public key of the server. So now we want the session key not to be revealed to anyone else. So that's why you encrypt the session key with the public key of the server, so that only the server can decrypt with its private key. So once the server, and then you follow it up with the username and password. So you see here until this point, the actual user who is working on the client machine is not involved. So whatever I said about the, when I say client, it's the client machine, the host. So here, only after this point, the user is getting in the picture. So you might have typed your username and password, but before the username and password is sent, all these things are happening. So now the username and password entered by the client will encrypt the public key of the server again, so, and sent to the server. So the server can decrypt it with its private key and check whether the user has an account and the password is the valid password and all these things. So once the server can authenticate that it's the right user, it can send a result of its authentication. And the result is again encrypted with the private key of the server, because you see here, you are not trying to protect the security of this message. This is just a result of an authentication, whether okay, yes or no. Similarly here, the name of the algorithm is selected is not that secret, because everyone can at least know by brute force search, they can find out what the list of encryption algorithms. By encrypting these responses coming from the server with the private key of the server, you're trying to make sure that the responses came from that server, right? So, because anyone can decrypt with the public key of the server to find out what is the response. So that's not the thing. The confidentiality of this responses is not what we want. We want to make sure that the message comes from that particular server. So we are not having any fake server again or a man in the middle trying to send all the responses. That's why we are encrypting all the server responses, the private key of the server, so that the client can validate it by decrypting the public key of the server. Okay? So this is how the execution. So after you get the result of your authentication, you can start sending your data packets. Okay, so you have to kind of go through this kind of validation and username and password verification and all those things before you, and then establish a session key. So everything that you send after that will be encrypted with the session key. So nothing is sent in plain text. Okay, so all your data that you are sending will be encrypted using the particular encryption algorithm that agreed upon and the session key. Okay, so that's the difference between like in like 10-15 years ago there was this protocol called Telnet, and I think it runs on port number 23. SSH runs on port 22. So you have to know the port numbers of certain protocols. Okay. If you ever used Telnet, I have used Telnet, and it sends things on plain text. So what are the username and password you use? Telnet is also like a remote login software, so you can use Telnet to connect to a remote machine. But its drawback is it sends everything in plain text. So if you're trying to send your username and password to log into the server, anyone who can run a Wireshark or any kind of packet analyzer can get those packets and find out the username and password. Okay. So with SSH, that's why since it encrypts everything that is on the channel, it's secure. Okay, so no one can find out what you're sending unless they know the password, the session key. Okay. Alright, so now let's move on to wireless security. So all of you use wireless devices, phones and laptops and all these things, right? But still there is a kind of difference in terms of the resources between wireless networks and wired networks and devices. Okay?
After that, quick question.
Yes.
What's the difference between some listening to my secure share and the kind of like five-way handshake is doing? What's the difference between that and the tunneling and transportation? You know the application, was it proxy tunneling? IPsec tunneling and